Have you ever looked at your enterprise AI bill and just thought, wait, how on earth did it get this high? If you're building with AI right now, you've probably figured out that tokens are consumed dynamically, they're priced asymmetrically, and they multiply completely silently with every single agent loop you deploy. Most teams honestly discover their AI bill the exact same way you discover a plumbing leak, basically after the water damage is already done. Well, welcome to this explainer. Today we're diving into a hands-on manual drawn straight from Paul Ranjan's Token Economics. We're going to explore exactly how to fix the root cause of these massive charges and unlock the absolutely most powerful cost optimization levers out there.
Okay, let's dive right into this. Think of today as a step-by-step masterclass on diagnosing and curing the problem. We're starting with the rereading tax. Then we'll move on to unlocking a massive 90% discount, explore a brilliant concept called the surgeon's tray, and finally, wrap up with some really clever techniques for long horizon agents.
Section 1. The rereading tax. Because before we can apply the cure, we absolutely have to diagnose the leak.
There's this quote from the source material that just perfectly captures the pain point so many developers are facing right now. It goes, "The context window is not free memory. It is a whiteboard you re-rent in full on every single turn." I mean, imagine you hire a brilliant consultant, right? But they can only think about what's written on a literal whiteboard right in front of them. The catch is, the venue charges you to rewrite the entire board every single time the consultant speaks. Early on in the meeting, it's super cheap, but 2 hours in, that board is completely covered, and you are paying to rewrite the whole thing for just one new sentence. That is exactly how a context window works. The real culprit behind crazy enterprise bills isn't some single expensive API call, it's your systems quietly paying over and over again to reread what they already know.
Just to put into perspective how fast this compounds, let's look at a standard 40-turn conversation. Let's say you're only adding about 500 tokens per turn. The cost doesn't just grow linearly, it grows quadratically. Turn 1 is 500 tokens. Turn 10 hits 5,000. By turn 40, your cumulative input is roughly 410,000 tokens. That is 20 times the final context size. This compounding math is literally the quiet engine behind almost every single surprise AI bill out there.
So, what does this all mean for us? And more importantly, how do we avoid this compounding tax? That brings us to Section 2, the 90% discount.
The source text has this really brilliant analogy for this. Think of prompt caching like dealing with a barista who has a flawless photographic memory, but zero tolerance for variation. If you walk into your regular cafe and just say, the usual, boom, your order is instant, it's cheap, and it's totally correct. You get a massive 90% discount on those tokens. But if you change even one single detail, say you ask for oat milk instead of almond milk right at the start of your order, the barista throws everything out and starts completely from scratch, and you pay full price for the whole shebang.
Now, what's really interesting about this is how we actually secure that discount on a structural level. To avoid recomputing attention over all those old tokens, inference servers store attention states in something called a KV cache. If your very next request begins with the exact same prefix, the provider just reuses those stored states instead of rereading everything. So the golden rule here, you absolutely must order your prompt elements from most stable to most volatile.
If you want to lock in that massive discount, you need to structure things in a very specific way. Step 1, your system prompt. This should almost never change. Step 2, tool definitions and schemas. Step 3, few-shot examples. Step 4, the conversation history, which crucially should be append only. And finally, Step 5, the current user turn, which is naturally the most volatile piece of the entire puzzle. So the crucial point to take away is this: never, ever poison the prefix. If you drop a timestamp, a random session ID, or even a shuffled tool list at the very top of your prompt, you instantly nuke the entire cache. No joke, this is the single most common caching bug in production. You've got to append to your history, never mutate it. And you really need to be measuring your cache read ratio as a primary KPI. I mean, moving a 12K token system prompt from 0% cached to 80% cached, that can literally pay for your entire platform investment in just a matter of weeks. But, static prompts are really just the beginning. Let's pivot slightly and look at Section 3, the surgeon's tray, which is all about context engineering. It's so common for developers to see a massive 1 million token context window and treat it like a license to be lazy. It's easy to just say, dump everything in. But if you do that, you're going to pay long context uplift prices for degraded output quality. Window size is capacity. It is not advice. What you really need is this masterful skill called context engineering. It's the discipline of curating the absolute smallest set of high-signal tokens that maximizes the likelihood of getting exactly the outcome you want.
To really bring this concept to life, think about a surgical operating room. A great scrub nurse doesn't just wheel the entire hospital inventory into the OR, right? They lay out exactly the instruments the procedure needs at that exact moment in the precise order they'll be used. And just as importantly, they clear away anything that is no longer sterile. Context engineering is basically being a scrub nurse for your AI models. You want the right information at exactly the right moment with absolutely nothing stale left cluttering up the tray.
And let me tell you, this scrub nurse mentality becomes absolutely critical when we move into Section 4, Long Horizon Techniques for Managing Context Bloat. When you're coding agents, they typically run in a loop. They plan, call a tool, read the result, think, and repeat. Because every single iteration forces the model to reread the entire transcript, your token count can easily explode from 12,000 to 200,000 in just 30 turns. To fight back against that kind of context bloat, the source text gives us a really brilliant 2x2 grid outlining 4 tactical methods to keep your agent's context lean and cheap during this long horizon work.
All right, let's run through these quickly. The first 2 techniques actively shrink the window on the fly. Technique 1 is compaction. Basically, when your transcript gets dangerously close to your context limit, you dynamically summarize the history and just restart the prompt from that summary. It keeps the flow going, but drops the token count dramatically. Technique 2 is context editing. So instead of summarizing, you actively prune. You drop stale tool results and old thinking blocks that aren't useful anymore. This is often way cheaper than compaction because you're just surgically stripping away what's irrelevant.
The final 2 techniques are all about offloading that memory entirely. Technique 3 is note-taking. Instead of holding everything in the prompt, the agent writes durable state, things like what's done, what's in progress, what's blocked, to an external file totally outside the context window. It can just go read those notes later if it needs to. And finally, technique 4 is sub-agent isolation. Instead of your main agent doing all the grunt work, it spins up parallel sub-agents for the heavy lifting. A sub-agent might burn through 50,000 tokens exploring a massive codebase, but it only returns a neat 1,000 token distilled summary to the main agent. This keeps your lead agent's context perfectly sterile, super focused, and incredibly cheap to run. I want to wrap up this explainer with a really provocative thought directly from the source text. When you look at your own enterprise AI systems, you have to ask yourself, are your agents carrying a focused tool belt, or are you forcing them to drag the entire hardware store into every single interaction? By mastering prefix caching, demanding the strict discipline of the surgeon's tray, and actively managing those context windows, you can literally turn a crippling AI bill into a lean, highly efficient engine. It's time to audit your prompts, stop paying to reread what you already know, and finally take control of your token economics.